Okay. Um, we will continue our MapReduce in the Hadoop. In the last class, I have written a program for word count. Word count is if any document or a text is given, a file. In that file, how many number of times a particular word has occurred. That we try to implement using the MapReduce processing. Okay, so MapReduce is actually an engine. The programmer will write program. Uh, uh, Creating a map per task and creating a reducer tasks. In that he will tell how he wanted to do the processing. Okay, so in the mapper phase there will be processing, uh, the processing which will give us a key value pair, and then the reducer phase it will be aggregated. The key value pairs are aggregated together and it will be giving the final result. Okay, this is what will happen. Last class it was not working for me because there was some problem with the multi node. Some node I told no, there were two nodes we have configured. In that, one of the was not listing out. Though the status was proper, but one of the node is not listing out. So that is the reason it was not giving the problem. It is saying dead node. And also we saw that there was some problem with the missing. So what I did to recover that is missing means if see we told that this all the data which we are giving, which we are storing into the HDFS, which we are putting into the HDFS, the text files or not, will be divided. Will be divided means the lines inside the text files will be separated in chunks of 128 megabytes and stored in the form of blocks in each data nodes separately. That's what I told. So that blocks were missing in some of the nodes. While it was trying to do the processing, it said it is missing. So what I did for the remedy for that is I did a name node format. Okay, I was not sure because FS image that has the information about where the data is present, right? So I have I reformatted it so that it will properly locate the blocks in the HDFS. Just reformatted it and that error had gone. Then afterwards, I stopped and started the process. Then I tried to run it. It was working fine. Just a moment. Okay, sorry about that. Okay, I will show you what I have done. Okay, and what is the map reduce as given the output today. Then we will further discuss like a complete workflow of what map reduce will happen and the phases in that. Okay, so I'll share the screen. Okay. The program I will show what we have written once more, and then we will go further. What I have done is I have created a folder, okay, in some location, anywhere in documents or direct or in your downloads, anywhere you create a MapReduce directory in that, so that we will put all our code, Java code into that and run it. Okay, so here I have created a folder MapReduce. Okay, inside that folder I have my code. Okay, this code of about the word count you can take it from the internet itself, but we will do exercises on other things, and you will also take an assignment to write your own code and execute it. Okay, so in this I have the uh, let's word count dot java program. Okay, the file name and the class name should be the same. So the file name is a word count. This we know it. Okay, so this is the file. This I have given here and there explanation that day. It will be in bits and pieces. Don't worry, we will relate it later on. I mean, once everything is completed, that flow, then it will be easy. So any programmer who is going to do a processing of your data in the MapReduce engine will have a map. Will write a mapper class. Okay, this here it is a tokenizer mapper. It is there, and he will override the method map, and in that he will tell what he has to do, how he has to generate the key value pairs. Okay, in my program I am dividing the complete the text in the input file. I will show you that about as of Nilet I showed, no, that input file I'm dividing into each word as a token and then appending it with a 1 1 to that. Okay, first this is the first phase. The output of the mapper function is going to be the input to the reducer function. Okay, these are I'll explain in detail. Okay, what reduce will do, this is the processing it will do. Say for example, two nilets are there, then it will combine together and it will give us a nilet. Occurrence of nilet is a 2. Okay, likewise. So this is the program, and we are also having we have also set up the configuration files. Which are the configuration files? This MapReduce engine should read it. Okay, every MapReduce it will start a job. Okay, actually the client, as I told that day, the client means I am the client now because I am writing the MapReduce program. Okay, I am the client now. Then I will tell I will submit this job to the resource manager. Okay, when you start it, it will submit the job to the resource manager, which is the Yarn will start every job. Okay, for the application which I am submitting. Application means the MapReduce program which I am submitting it. It will start the job. So for that job, I'm giving the name as a word count. Okay, this is just a name, and what configuration files it has to look into. The configuration files like the XML files which we have edited. No, so MapReduce job will look for the mapred.xml file that we have edited in our etc or Hadoop folder that it will refer to. Okay, and we will give all the class files. Class files is these are the compiled files, right? Those file information we will provide to the job. Okay, a job is like it will count the number of times a particular word has occurred from the document, likewise. And we will also give the input path. Okay, what is the input document, input data, and the output path where the output has to generate. And we will tell what it has to do at the time of compilation. Once Sorry, at the time of completion. Once the job is completed, what it has to do. If the job is successful, then it will return 0. Otherwise, it will return 1. Likewise. Okay, this is like system exit. The exist is like the particular job is completed. Then wait on completion. What it will do? It will do is it will give a 0 or 1. This is a success message. Okay, so this is the code. This code I will first compile it. Okay, this is a Java program, right? I'll come out of this. Wherever the code is written, first after three steps you will do after writing the Java code in Hadoop. First, you have to compile that code in the Hadoop environment. Okay, that will generate the class files. You remember, right? When you compile a Java code, it will give the class file, which is the byte code, right? And that one you will jar it. Jar it means you will compress it together. Jar means we will do tar, right? We will compress the files, right? This WinZip, no? Likewise, in Java, in order to, that is the library, you remember, that we used to see in our Eclipse and all, there are libraries, default libraries from jar. Likewise, this all these class files which we are generating, that we will put it into a jar, and that jar we will use it to start the MapReduce job. So that I will show. Here already class files are there. These are the class files generated. I'll remove these class files and I will generate it again. Okay. What I will do, I removed the class files, and I will remove this also. So only these are there. We will, what we will do, we will put this content, that is word text.txt. I have a document that we will put it into HDFS. Okay, HDFS file system. I'll open and show what is there in this document. Okay, word text.txt. So this is some content which I have taken from about us, about Nilate, okay, that I have copied and put it here. So what I want the MapReduce job to do in this document is to find the number of times each word has occurred, how many times of word has occurred, how many times a Nilate has occurred, how many times government has occurred. Likewise, it will list it and give. Okay, so that I will do it. So I have written the Java program. Now you can assume it. Now we have to compile the Java program. So the steps you can note it down, guys. Okay, the steps, because you have to do the steps. In exam, you will have a MapReduce program. Surely it will come. One MapReduce program will come that you have to do that. Okay, so I'm going to refer to this tools.main. Before doing a compilation, you have to set the Hadoop class path. Okay, that I have set it that day already. I'll show you what it is there in that. Since I have set it, I am showing as echo. Okay, it is not set. What we will do, we will set the path. It is set in this one, I think. Yeah, this is the path. Okay, this is the Java tools.jar. It will refer. Okay, that's why this path we have to set. If it is not set, you set it like this. Echo Hadoop variable name is Hadoop class path equal to dollar Java underscore home. Okay, that tools.jar is in Java underscore home, and then lib slash tools.jar. Okay, it will. I set the path. See, it is a set. If you go and see, it will be there otherwise, but it is not showing. Okay, what I've done is it has to be export, right, not echo. You have to export the path, otherwise you can set it in your bash rc file also, no problem. It will be there in all the prompt, whatever the shell we open, no, the terminal, it will be available there. Okay, it is a set. Okay, this is a fine. Now we have to compile the Java code, word counter.java. How do we do that? Hadoop com dot sun dot tools.java c compiler. This is the compiler dot main. Okay, actually we are giving the path. Okay, where that main class is there, that path we are giving it, and in that the file name is word count dot java. Okay, word count dot java. Then I will enter it. This is just a warning. Okay, this is not an error, so it is a fine. Otherwise, it compiled it. I will show you what it is giving the class files as. So we have written, if you remember, three classes. One is the tokenizer mapper. If you go and see that class, we have word count.java. Tokenizer mapper. Okay, this is one class. This is a static class. The another class which we have written is int sum reducer. Okay, these two classes along with the outer class. Outer class is the word count class. So all these classes are generated. Okay. Okay, all these classes are generated. Now what we will do, we will create a jar file. Okay, that will contain all the class files. Okay, how do we create a jar file? Jar ICBF. C is the compress. Okay, V is the verbose. Verbose means it will show, and F is the file. Okay, this is the abbreviation for this uh, uh, command. And what should be your jar file name? I will put this wc.jar. Okay, this is the name of the file which I'm wanted to create. And what all it has to go into the jar file? All these class files. Okay, so I will give like w count star dot class. I'm not typing everything. What I do, w count, the complete thing it will take. It's a wildcard character, right? Wildcard character dot class. If I give, it will take all the class files which are in this folder. Okay, enter it. So it has generated, okay, all this int sum reducer, tokenizer, map, everything is into the jar file wc dot jar. You can see the jar file will get generated. Okay, this is the jar file created. Okay, guys. Then after that, we have to start the map reduce. So you are taking the steps right along with me. Just note this down somewhere else, everyone. Amalan, are you taking Praveen, Maria, Prakash, Saurav, and Venkana Babu? Are you all taking? Because these three steps you have to do it. Just note it down. This one will compile your Java code, whatever this is word count. So otherwise, whatever you are writing it. Next, you will create a jar. Okay. And the next one you have to okay, jar is created. Now we will run the MapReduce job. Okay, wherever the jar file is present, there you will start your MapReduce. Before that, we will see whether our processes are running. Okay, so all the processes are running here. So what I will do, this is how you will start your MapReduce. Hadoop jar and the our word count dot jar. Okay, and the class name, the main class name we have to give it here, which is nothing but a word count, and input file path. See, the file I told that I will take this document. um, I'll take this text word text dot txt document and find the number of words occurring in this document, right? So this document has to be present in the HDFS, right? Because it is there in the local directory. If you see Hadoop fs-ls slash, this is the root directory. So there, this Word document I have not put it. Okay, it has some temp today dot text and all, but word dot text I have not put. So what I will do, I will put that the Word document from the local directory to the Hadoop. So what is the command for that? Hadoop fs hyphen put locally. I have word text.txt. I will put it in the root directory. Okay, slash I will give it. So first, I mean, before starting the MapReduce job, it will go and search in the HDFS, right, where your document is present, right? So that is the reason I am putting the file into the HDFS. So this is the command I put it. This Java program can be saved anywhere, Saurav. It is not necessary that it has to be in a Hadoop place and all, Hadoop installation folder and all. It is not necessary. Okay, the jar we are creating, right? You will start wherever you give the jar file. Okay, that path only you have to mention it properly because it reads the jar and it will start the job. Okay, I will show you. Like Hadoop, the jar, here I will mention the jar. Okay, this jar, since I am in the current directory, that is MapReduce a directory, it will not I don't have to give the absolute path directly. I'm giving Hadoop jar wc. Okay, that is my jar file. And what is the class file? Okay, class file is a word count, right? That is the class file, that is the main class file that I will give. And the input file from the HDFS, input path and output path we have to give. Okay, I will write it like this first. Hadoop jar, the command will be like this. And jar file name and class name Then input path. This is HDFS input path. Okay. And HDFS output path. We will mention those two, where you wanted the output to be generated and where your input file is there in the HDFS. This is the command. Okay. This is how you have to write the command. I'll enter this. I'll write it Hadoop jar. My jar file name is wc.jar and the class path is class name is word count. Okay, then input file is root directory. I have a word text. Okay, .txt. Okay, root directory means this is the HDFS root directory. Okay, and output it will generate. So what I will do, output I will give. Okay, everything will generate in HDFS as a directory. Okay, this directories will contain files inside it that we will see. Okay, once I will enter it, it will start the MapReduce job. Okay. Okay, it will connect to the resource manager. You can see it here. And there is something like input splits and all that I will talk. Okay, it is running the job. The job ID is given it here. Okay, and these things are some information about it. Then it will start map task. The map task has started. It is 0% complete. Reduce task also has started and that is 0% complete. First map will run. Okay, it is done 100%. Then reduce will be done. If it is not having any error or no dependency, it will run. So it is a success. Okay, I can go and see. Okay, here it is. It's saying the job. Okay, that job reference only we have given in our code, right? That job has a job ID. This one is for any debugging purpose. We can use the ID and see, and it has completed successfully. So map is 100% and Redis is also 100%. Okay, there are set of counters which are associated with each of the jobs. Okay, that it talks about number of bytes. It is reading, written. Okay, reading means reading from the HDFS. Okay, in HDFS only it is stored, right? And writing back, your output will be returned back into the HDFS. So if you see this command, we give the output path, right? Input path. If you see this command, this is the input file path. Okay, file path or input path, and this is the output path. Okay, it will read from the HDFS. It will write back to the HDFS. Okay, that's what the return number of bytes it is showing. Read operation, write operation, and it will also have a counters. Okay, counters will say that number of map tasks started, reduce tasks started. Okay, job, how it will get divided is job tracker. Initially we had a job tracker and a task tracker. Job tracker is actually the resource manager. Now it is from Hadoop 3.0, it has changed to resource manager, whereas a task tracker is the node manager. Okay, node managers will run in data nodes where the actual data is present. Okay, so what it will do for every job which is submitted to the resource manager, it will divide into tasks, multiple number of tasks. Okay, uh, each task for each chunk of data in detail I will explain. Okay, now I wanted to show how the MapReduce works and how the output is coming. Okay, here only tasks like one task has started because it is running locally only. This MapReduce job is running locally, not in different nodes, because I have changed some configuration, right? Because it was giving input output, sorry, error. So that the counters information are all present. Total time spent on all this information will be present. Milliseconds, the core used, okay, core space used, the records, okay, output records, how much it is generated, all this information. These records are all like it will divide the data. Okay, the complete document I am giving, right, for running the document word text.txt I am giving for the MapReduce job to process, right? That it will divide it as a separate records. That I'll tell again. Okay, we'll go in detail. Okay, so this job is successful and it will have all the counters and all. You can go in detail about the counters. You can read that book which I have given. No sorry, Hadoop. Yeah, definitive approach. No, that book is very good. There also you can read all these things. the physical memory it used and the virtual memory, all these things it will be giving here. Okay, if anything wrong in this counters, then you can see it. Okay, so this is the input file format counters, where the bytes read is this much and the byte which is written back to the HDFS is this much. Okay, so where the output, I told it is successful. So where do we see that where do we see the output? The output is the number of times a particular word occurred. Where do we see it? It is written back into HDFS, right? So we will traverse the HDFS fs hyphen ls. I'm listing it. Okay, here you can see output directory created. Output directory. This is the directory name which I gave when I start the MapReduce job. Okay, output directory. See, it is a directory only. Okay, we will go into the directory and see what it is there. Output. Okay, it has a two files. Okay, two are the files. Okay, these are files. One is the success file. This talks about the status of the file, and this is actually part underscore 00. This is a one. This is the file which contains the actual output. So we will view what it is there. What is the output in that? As I told, we cannot do a VI. Okay, we cannot open the file from the HDFS using any editor, nano editor or VI editor. Nothing you can do. Only thing is you can cat the file. Okay, the file is in output and the part. I'm going to view this file part hyphen r hyphen this. Okay, so it will give the output. See, now you can see the output. This is the output. I'm going to the start of the one. Okay, see each word, it is how many times it has occurred, it is giving. Okay, I'll go to the top. So here you can see that and symbol has occurred 4 times. 36, okay, open close brackets has occurred once. Nilet Ernest has occurred once. Each word, like with word has occurred twice. Two has occurred thrice. The word has occurred 9 times. State of the art 1 times. So it will divide all the word. So if you see the file is word text dot txt. Yeah, I made a ls. It should be cat only. You can view the file content. So this is the content of the file. So if you see that the located and all would have occurred only once. Delhi would have occurred only once in this document. So this is how you will run, right? See, this is how you do the processing. So you are doing a processing in your machine learning, right? Some data set you are taking it. We will see with the data set, the further examples will be like that. You'll take the data set and you will do the processing, right? Similarly, the Hadoop gives a facility or the environment to store your data, and you can also do the processing in the data. Okay. So this is one example. Is this clear, guys, till now? What it is doing? I have written I have written a MapReduce program to do a processing. The processing for me is like I wanted to count the number of words, number of times of the word occurs in a document. For that, I have written a map job, a map method, and also I have written a reduce method. Normally they'll say function only, so I'll say it as function, map function and reduce function. So both the map function will take the input of the document, okay, and generate an intermediate key value pairs. Okay, the reduce task, what it will do, take the input from the map, the output of the map, and aggregate it together, okay, and give the result. Okay, till now is it fine? Please tell me, then we will see the in detail what it is, how it is happening. Is it okay? Amlan Maria Prakash Venkana Babu. So can you tell me that you have finished installation at least a single node cluster, single node Hadoop? Have you done the installation? I think Saurav, you have done it. Others, Prakash, you have done it. At least you should have single node. Okay, multi-node is for your practice. See, for multi, whatever the data I put right in the master node, in the HDFS, it gets replicated in the slave nodes. I will show you end of the class. Okay, that you don't have to replicate yourself. We have given in HDFS site.xml the replication factor right to that XML file. It automatically gets replicated. Okay, and how it is dividing the chunks data, how it is storing in, how it is choosing the data nodes to store the data and all. It is all internal, but you can understand the overall idea like how it is done. Okay, some algorithm will be there to store the data, choose which data node it should store the data. Everything is done internal, and how the MapReduce is doing the processing on the chunks data. I will show it in I will explain the workflow, but internally we cannot view it like the processing is happening here, the processing is happening here. Maybe in administrative level, if you learn it, then you can go and see where it is actually happening. Okay. Okay, you have installed, no? So what you will do today is you take this word count program. Okay, it is available in the internet itself. This is famous because they'll start with this to make it the understanding easy. Word count program tutorial you can search. Okay, Hadoop MapReduce tutorial, and you will have that Hadoop site. Okay, in this site itself, they have this program. You can, for time being, if you don't understand, you can copy and run this and see. Okay, then later on you can understand the workflow also. So this is the program that day itself I showed. You can just copy it. You have compile the code as I showed. How do you have to compile? Create a jar file and start the map reduce. See if any out error is coming, and also see where it is stored in your HDFS. Okay. Hope till now it is fine. So we will move on to learn how it is actually happening. For that I will share a slide. Slide is visible to you all, right? Okay. So it is a software programming paradigm, okay, in your Hadoop. As I told, it has a Hadoop environment or a Hadoop ecosystem has two components. One is the storage unit, which is HDFS. Another one is the programming unit, which is your MapReduce. Okay, it has an engine itself. The engine itself will do all these things. Whatever it is doing internally, it will do that. Okay, so it's a software framework for easily writing application which processes vast amount of data. Okay, it happens, processing happens in parallel. So as I told, the document that is that wtext.txt document, inside all we have a number of lines right inside that. Say it has a 10 lines. Okay, say the first 5 lines comprises of 128 bytes, megabytes. Okay, this will be divided, okay, segregated, and it will be stored in a block in one data node. Okay, 128 megabytes, which is a consisting of 5 lines. Similarly, another 128 megabytes will be stored in another data node. Okay, in another data node as a block. Okay, so what I told, the wc.jar, okay, that is the program uh, jar file, right? After we have written a program, word count program, and we created a jar. That jar is containing the processing logic, right? So this processing will happen on this data node 1 with 128 bytes, and it will also happen in data node 2. So it will happen parallelly. You can see that. So it will happen parallelly, and it gives a key value pair as the output. Okay, after this two key value pairs will get aggregated. Okay, that is done in the reduce task. Okay, reducer phase, right? Reducer program, that it will aggregate this key value pairs together, and it gives a one result, which is again a key value pair only. Okay, in each of another documents, now we are seeing just a text document. If it is a CSV file records or a data set, how it is giving the output, I will show. Okay, so that's what they say, that it works in parallel on a large clusters. Say if it is a 1,000 lines of code and it is divided 10 times and it is stored in 10 nodes. So all 10 nodes will do the processing. This you can understand. No? So as I told that example for the mm, for a departmental store I told, right? So you say for example if they have 4 floors and each person is working in each floor. Okay, each one will give an output. Okay, this is the map phase, you can think. All this aggregated together to find the total number of output, that is the reduce phase. Okay, so it will work in parallel in on the larger cluster. The number of nodes increases also, it is not a problem at all. It is a reliable, we know that, because data are duplicated. In that way it is a fault tolerant too. Even if you lose the data, if the data node, some of the data node is down, you can get the data from the other node. Okay, you can get means the job will search. Okay, the Hadoop framework only will find that block from other node and it will start the processing from there. Okay, so MapReduce is the job usually splits the input data set into independent chunks which are processed by map tasks in a completely parallel manner. That's what I told. It will divide your data into splits. They call it as input splits. Okay, it first whatever the document which we sent itself will be divided. I told no, it is divided. The first 5 lines are divided and is stored. Storing of first 5 lines will happen in the framework itself. But what this map reduce will do, say I have it in a data node D1, okay, data node 1, 128 megabytes of data. Okay, this data, the MapReduce engine will split. Okay, if it is a 5 lines, it will split first line as a key value pair and second line as a key value pair. Okay, for that I will show you how it will do it based on the offset side. Okay, independent chunks, it will divide it, and for each chunks it will run a map task. Okay, that it will give it in a parallel manner, it will start the map task. That's what they are saying. The framework sorts the outputs of the map, which are then input to the reduce task. That's what I told. Altogether, the map task's output, the output from the map task will be the input to the reducer task. Okay, that's what they are saying it here. The framework takes care of scheduling tasks, monitoring them, and re-executes the failed tasks. This is all taken care by the framework itself, like scheduling the tasks. Okay, who has to run the job, or who has to take the task, which data node has to start the task, and all those things are taken care by the framework itself. Okay, uh, see, before we are writing mapper task and reducer task, right? Before that itself, there are many activities will be happening. See, the programmer will write map tasks and a reduce task. Okay, and it will be stored in the HDFS. Before that itself, the document which I send, like word text document, it gets splitted, it gets stored in different data nodes. In different data nodes, again, it will be converted into key value pairs. The input to the map task itself is a key value pair. Okay, again, it will generate a key value pair, which is the intermediate result we call, and this will be the input to the reduced task. This is how it happens. I'll tell in detail, so don't worry. One by one, we will go. And the nodes and the execution, how it happens is, like typically the compute nodes and the storage nodes are the same. Compute nodes and storage nodes are the same. Can you understand this? Computation node and the storage nodes are the same. Can you understand this? What they're saying is the data node. I told no earlier, the computation happens on the data node itself, where the data is present, not in the master node. Computation means the map reduce job which I am starting. It will happen in the data where the data is present. That's why they are saying the storage nodes and the compute nodes are the same. Okay, the MapReduce framework and the Hadoop distributed file system are all running on the same set of nodes. MapReduce framework can efficiently schedule the task on the nodes where data is already present. Okay, that the MapReduce engine will start the tasks on where the data is present. As I told that day, see if we think like this as the master and many data nodes are present. Okay, okay. Rather than bringing the data to the master node and start the processing, Hadoop MapReduce task, what it will do, the wc.jar, right? It will go to the data node. Okay, that is the jar file where we have our logic. That it will start processing in each of the data node. How it is happening? How that is all taken care by the framework. Okay, because if you see, I run that Hadoop jar that map reduced job, right? I started in the master node only. Then you can ask me, ma'am, you are starting it in the master node, but how you say that it is happening in the data nodes? So that WC dot jar, that logic is actually transferred over the network where the data is present. Okay, we don't have to transfer it; it will taken care by the framework itself. So that is what the distributed. That's how it can work distributedly, right? The job can start here, the job can start here, the job can start here. If we bring all the data to a single node, then it is not a distributed or parallel processing. We can also say it as a parallel processing. So that will not happen. And high accurate bandwidth across the cluster. Bandwidth should be good so that the movement of the data or the movement of the logic or the movement of the jar files from one from where the job is started should be smooth. Okay, otherwise if network bandwidth is not as reliable, then you will not get the result as expected. Okay, some of the results you cannot get it. Why? Because data is present in some of the nodes, will not we cannot retrieve that data and view it, right? That's the reason they are saying it. Then anatomy of the map reduce. So it is like a single master resource manager, worker node manager in every node, and a MR map application part. See how this happens is the engine works is first a client submits the job. Okay, submits the job means says run a map reduce job. That it will go to the yarn. Okay, that where the resource manager is present, as I told earlier. Then yarn will uh, delegate it to the node manager. Node manager will be running in data node. You can open and see your slave machines. There will be node manager running in that. Okay, node manager will be running in the data node, and this will start the application manager. Okay, which will take care of the jobs running in the data node. Okay, so anything client here you can think of this a client. That's what they are saying. It is a single master resource manager. Okay, it consists of single master resource manager. It consists of the worker. Okay, work is the node manager, which does the task. Okay, which starts the tasks, each task, and it will run it. And the application master, for each application, you will have an application master. Each application means I am as a client giving an starting an application as a map reduce. Say some other client can start a application in pig. Okay, that will also internally start a map reduce job. Or if he is using the application hive, it is possible that to a single mm, Hadoop framework, you can have any number of application connected. Okay, pig also can do some job. Hive also will do some job. We will see that in detail how it is. Okay, so each of this application will be managed by the MR application master. Okay, each application will be given as an ID, and it will track with that which application is running where and all those things. Okay, and MapReduce applications, it will have the information like input, output, location, supply map functions via the implementation of appropriate interface. So these are the things which the developer will do. Okay, if it is a MapReduce application, then application How I will write the application is like I will give the input output location from the HDFS, and I will also give the functionalities for the mapper task and the reducer task. What the mapper output should be and how the reducer output should be. That information I will give it here. Okay. And the other job parameters which are in the main method we give all these things. Okay. And although the Hadoop framework is implemented in Java, MapReduce applications need not be written in Java. Okay, framework is written in Java, but you can also write this MapReduce jobs in Python. The Python code is very simple, guys. Only 4 lines of code. Okay, you don't have to write all this inputting and all in that. You can try it with Python also. Okay. So about this slide, they say that the MapReduce framework will have a resource manager which it will connect with. It will also connect with the node manager. The node manager will divide your job into tasks, okay, and start running. And the application master, uh, uh, keeping tracking of to keep track of which are the application who are going to run the map tasks likewise. Okay, and the application MapReduce is an application, Pig is another application, Hive is another application, Spark is another application. So when you are going to write a MapReduce application, you will give the input and output location of the HDFS where your processing has to done. You also give the business logic or the processing logic that we have written in our word count.java file, right? That logic and other parameters. Okay, that is how the framework will be working. Till now it is fine. Am I going fast or is it okay? The pace. Okay, Maria said okay, then I will move further. So it operates exclusive on the key value pair. That's what I told. The document which we are sending, right? We are using, right? Word text dot txt document. The complete document will not go for our processing. Okay, it will initially be divided into key value pairs only. How this is done? It will be done based on the offset. You can imagine that the file is having, I'll open the file. This is the file, right? This is the content of the file. How the it will not go as such. Okay, you can imagine that each line will be divided into a single uh, key. Say for example, key value pair. This complete line it will be divided and it will be appended with one. Okay, the first line is a key and comma value is one. The second line is a key and the value is one. Likewise, it will divide. You can imagine here it is like each line is divided and that is the input to our whatever the code I am writing, right? A map reduce code. That is going to be the input to that to my program. Okay, before itself how this is done, we don't have the control of dividing this. This is done internally by the framework itself, and it is done based on the input file format that we will see in little in the next class we will see. Okay, so input to your program which you are writing as a map reduce program, the input to the map itself is a key value pair. Okay, so how I can show it, right? In our word count program, in our word count, see, this is the class file which we are writing for the mapper, right? So here itself, for the mapper function, it takes the input as a key value. Okay, the mapper function, what all type of input and output it will provide, that's what it is given here. Okay, the the class which I write, it is extending from the mapper class. The mapper class will take a key as a input, value also as a output. Key will be of type object and value is of a type text. Text means some string document or text document. Okay, this is specifically this type, right? The text type, data type. This is the data type, right? This is given by the Hadoop classes, okay, which are specific to Hadoop. And the output is going to be a key will be of a type of text, and the value will be of a type int writable. So if I write it here, this is the input key. Just a moment. Input key, input value, and you can think that it is output key and output value. So input key, now you can think like how we say that mapper task will generate an input intermediate result, but input itself to the mapper will be an input key and input value. That's what I told. The complete document, it will not be sent as such. It will divide that document itself as a key value. Okay, that is based on the input format type that I will talk in detail. And about how it actually happens is it will divide as a offset, okay, offset number of characters, and it will append it with the offset that I will tell in detail. Okay, this you can imagine like map itself will have an input of a key and the value pair. Okay, first line you can imagine now as the first line as the input is a key, and the value is like it is appended with 1, and on that first line only this tokenizer will happen to, it will tokenize the each data, each word, and it will add 1 to it. Okay, 1 we have asked to add here, so it will add 1 to it. Likewise it will do. And that's what they're saying. The MapReduce framework operates exclusive on the key value pairs. So the input to the map task itself is a key value pair. The key and the value classes have to be serialized by the framework, need to be implement the writable class. See, serialization actually, all you remember that we have learned the serialization in Java, right? You remember what is the serialization in Java? It is like converting the objects into bytecode format, right? So what they all the key values in MapReduce, they are in the serialized format only. So how the serialization happens? Who does that? Everything is taken care by the framework. Why it is a serialized? Can anyone say why the data or the key value pair they are saying should be serialized? What is why do we do serialization? We have learned it, right? Why are we doing serialization? Come on, speak up. What is serialization in Java? Yes, bytecode conversion, but why do we do it? No, serialization, why do we do it? You remember that we compress the data into a byte format and share it over the internet. Okay, so it is also one of the advantages of providing the security. Okay, here in Hadoop, it's a distributed environment. We told distributed means all nodes are connected to over through the internet. Okay, some wiring will be there, So connecting between the internet, like data transferring from a master node to, not master node, from node 1 to HDFS, between the HDFS or through the internet. Okay, that is the reason that the data will be serialized form. You cannot send as such whole data. Okay, that can be tampered. Security purpose also it is there, and if you convert into bytecode, the space used will be less. That's the reason that the complete transferring of data in Hadoop, right? It will be done in a serialized format only. Okay, that's why we have seen serialized in Java also. Okay, and additionally, key classes have to implement the right comparable interface to facilitate sorting by framework. See what they are saying is, first you are sending a key value pair input to the map. Okay, it gives a intermediate results, which is again a key value. So in our case, I say nihilite. Okay, nihilite has occurred two times. I could not write it here because of the mouse. Say I say nihilite has occurred two times. Okay, which way I'll write it in a document. So if you take that document, then I can say, so input to the document will be like a key value pair. Input to the map function, okay, will be like a key value pair. Okay, so what it will do, it will again say we have seen the national, and it will append it with one. This is what we are asking to do in a map task. Okay, appending it to every word whichever has occurred, like annihilate, whichever has occurred as one. And we saw a word the, right? The has occurred 8 times, but after the map reduce output, we will have it like this. Okay, the has occurred one time, 8 number of times we will have it like this. One, right? So say we think like it has occurred 4 times. The has occurred once. Okay, so this is the map phase. This is the output after the map phase, and after the reduce phase, I'll just copy and put it here. See, after the reduce phase, the key value pair from output of the key value pair, whatever is this, that is going to be the input to the reduce phase. Internally, there are many phases which will be happening. Okay, the phases are like a partitioner, combiner, shuffling and sorting, and all happens. Shuffling and the sorting means, in say for example, these two output, okay, the comma one. Say for example, I'm getting this output from a data node 1, and these two I'm getting the output from the data node 2. Okay, so data node 3. Okay, data node 2 is giving some other output, like here also annihilate is there. Okay, like this it is giving the output. So shuffling and sorting, it will sort. Okay, it will shuffle the data from a different nodes in the reduce phase, and it will bring it together. Okay, that's what shuffling and sorting, and it will add now it will become the output of the reduce phase will be like this. I will explain again, don't worry. So annihilate has occurred twice. Then it will be like this. So the input to the map phase itself, a single line you can take, like first line 1, comma, one time it has occurred 1, or line 2, comma 2. This I also explain in the other next slide. Okay, so now you can think that the input to the map phase is going to be a key value pair only, and each line it is going to add 1 1. How many times it has occurred? Here I told in my program to add one. Okay, anytime the number of words occurred, I just add one to it. Okay, it keeps adding one. Okay, then after that, passing through different phases, the output in the reduce will be like aggregated one. Okay, nilet has occurred twice, the has occurred twice. Okay, why I've thought of explaining you this one is here. Okay, here what they say is additionally the key classes has to implement the right comparable, because they will do a comparison. Okay, comparison between the data. Here if you see it, they will do a comparison in between the data, and it will aggregate it together and it gives the result. Okay, for that the right comparable interfaces has to be implemented, and facilitates to interface to facilitate the sorting by the framework. So this is taken care by the framework only, the sorting phase and the where is that? The sorting phase by the framework is the is possible only by is done by the framework. The sorting and shuffling, partitioning or combiner, all this done by the framework itself. Only thing is we will see the aggregated output. Okay, that's why I thought of showing it. We'll see in further what other phases are internally present. Okay, now you can think of that input to the map function, what we are writing itself is a key value, and that it will again generate an intermediate result, and that gets combined. Okay, and gives the final output as a key value, which again gets stored in your HDFS. Okay, this I have shown. And is this okay till now? We have an overall idea. In detail, we will see. Okay, shall I move on further? So about our word count program, here it is like if you wanted to write a word count program like this, we have to set the class path. Okay, class path saying that it will take the libraries of from tools.jar. Okay, Java itself have a tools.jar. That path we will set. We will compile the code. It is there in the slide also. Okay, we will compile the code mentioning the main class. Okay, Java C is the tool that will compile word count.java, and you will create a jar file. Here they are creating a jar file wc.jar. Okay, use which are the class files you wanted to combine together, that we will mention. Okay, then we can make a directory where your input data should be present in your hdfs and where you want your output data. Okay, put the files into your input directory. I have put it in root. You can also create a directory and put it. Okay. And you will start the map reduce job like this. So this is the command. In Hadoop command, you will specify the jar, which is a jar name and the class name. Okay. And you will give the input file path and the output file path. Okay. Then it will start the map reduce job. Then this is about the configuration which we have written, right? Here you will specify the jar class. The main jar class which it has to refer, the main program has to refer is, see, it will hit here, right? Then it will read the configuration. It will start the job. Okay, for the job we are setting which job we have to tell, right? Which is your main class file, and main class, which is your mapper class, which is your combiner class. This class I will explain in detail. This class is like an intermediate class, not intermediate, it's like a mini reducer. Okay, before going to the reducer, this will do some activity. It is an optional class. Whether if you wanted to set it or not, it is based on the user decision. Okay, and then the reducer class we will set, and we'll also set the output key class, how it should be. It is a text one, and how our output value should be, it is int writable. Okay, and this is the file path we give, add input file path. This we have given that input directory from hdfs, no, here input file path. Okay, and this is the output file path. So this will read input file path and output file path. Once it is completed, it will give us the successful result, otherwise it will throw error. Okay, so this is the mapper function which we have seen. uh, Here you will rewrite the mapper function. Here what I am doing is each of the words from the file I told, we will tokenize it and we will store it into an iterator. The iterator will keep looking for next items. Okay, and that it will write it to the context. The context is nothing but the Mm. The right comparable we have seen no, here in another slide. That is the place. The right comparable, implement the right comparable method. That is the context will write your data into the HDFS itself. Okay. You can ask me how, why it is going to temporary. It will create a temporary directory. Okay. The output of the map also will be present in the HDFS temporarily, because uh, uh, somewhere it has to. We have to store it, right? We will store it into a context in HDFS itself, and then so this is the output data after mapping will be, say for example, there is a word one, and it is from node 1, 1 it will be there. Word 2, 1, because we are appending it here with 1. Whatever the word we are reading, we are appending it with 1. Okay, appending it with 1. Okay, this one we say it as an int writable object. We are doing it like that. So word 2, word 1 again has occurred once. See here we are not aggregating it. You can see the difference. We have not aggregating like word 1 comma 2 times it has occurred. No, after the mapping phase we don't aggregate it. We will only do a transformation. So normally mapping they will say it as a transformation of a particular document or data set. We pass it into a different format, key value pairs. Okay, word 5 has occurred once we are appending, and in node 2 word 7 once. See word 1 has occurred here also 1, word 9 has occurred here 1, and word 5 has occurred 1. After this phase, what we will do, we will go for shuffling and sorting. Okay, so all this whatever the words are related together, no, all this will be put it in a single list. Okay, word one, here word one is there, here word one is there, all these things will be put in a single list. Okay, and it will be counted uh, after this phase. In the reducer phase it will be counted together like a word comma 3. The output will be like word comma 3. That is what the reduce phase will do. The intermediate things, which is like shuffling and sorting, all taken care by framework. Okay, how it is taken from each node and how it is a shuffling, everything will be taken care by framework. Only you will write your logic to do an aggregation and transformation. Okay, the code for this is here for the reduce task, which we will do. We will actually do the sum from the list. Okay, this is the sum. So input to the reduce I told like it is the output of the key value pair from map. So key is a text format, and value is the int writable list. Okay, this is a list, iteratable list. Okay, see this it will generate it. Okay, after shuffling it will generate it. The framework will give us the output like word comma one, word comma one, word comma one in a single list. That it will pass it to the reduce phase. Okay, then what it will do, it will do a sum here. Okay, it will do a sum here and it will give an aggregated result like this. Word 1 comma 3, word 2 comma 1, 5 comma 2, word 7 comma 1, like this it gives the aggregated result. Okay, so till now is it fine, the overall? So you can imagine in any map reduce things, you will get map reduce will have a reproduce a read key value. Again I'm saying, and sorting and shuffling and from different nodes all happens inside before it goes to the reducer phase, and then reduce gives an aggregated result, which is the one which we are seeing it here. Okay guys, is this okay till now? Okay, tell me, you don't have any doubts or any query? You should be having doubts. No doubt, Prakash, you don't have doubt. Venkana, Babu, Amalan, Maria, Saurabh. Okay, fine. Okay, another slide about the MapReduce workflow. I will share it. We'll discuss that. We'll after that we will end it. So MapReduce in depth we will see what is the workflow, what are the phases involved, and what each phases does. That we will see. Okay. I will try to write. The thing is here I could not write it. Otherwise, in the next class, I will be back in office. That time I will draw it once more. No problem. We will revisit it also. Okay. Map reduce in depth. In depth. This is how the format it will go on. Okay. So for example, you can think that your data is in two um, nodes. Okay. Data node one, data node two. And in data node 1, each one will have the HDFS, right? Each data node will have a storage space. Okay, in that your file is present. Okay, so the file is taken for the MapReduce job. The before this is the phase we are writing it. The programmer will write. The code will start from here, guys. Okay, your code will start from here. In this phase only, you will tell how you want your intermediate key value pairs have to be generated. All these things are taken care by the framework itself. What it will do, it takes the file and it applies an input format. Okay, input format is based on the file, whether it is a sequence file, whether it is a video file, or whether it is a binary file, or whether it is a compressed file. Okay, based on the files, it will divide the file or the data inside the file into splits. Okay, this they will call it as a input splits, not based on the file, based on the input format. That's what each file I tell you, right? Like if it is a compressed file, or whether it is a binary file or a streaming file, like image files or video streaming files. So each file has an input format. Okay, that I we will discuss in the next class. Based on that input format, the split will happen. Split means the file data is divided. Okay, so that we call it as an input file. Sorry, input splits. Mm. Mm. And then it goes to the record readers. What this record readers will do is it will take the input splits, okay, and converts them into a key value pairs. This is the key value pairs, okay. This it take the input split data and converts them into the key value pairs, which is used for doing the mapping tasks on the key value pairs. So the code which we are writing, this mapping code, that will work on the key value pairs, which is given by the record writer. These are the phases, okay. And after that, once after the mapping code which we have written, it will generate as the key value of intermediate result. That it will go to the another phase like a partitioner. The partitioner, what they will say, like this partitioner, it will tell like how many number of reduced tasks or the reduce has to be is needed for the mapping mapper. Okay, so reduce will do an aggregate from the mapped output, right? So how many reduce tasks is needed? Only one is enough to aggregate the data from different nodes, from node 1 and node 2, or it needs a more number of um, more number of reduced tasks. Like that information this it will give. And after that it will go for sorting. See, it is connected with another node also, right? So that if word 1 word comma 1 is here, and first word is word like cat. Okay, cat is here and cat is also here, cat is also here. So this is sorting phase will shuffle the data. It will take the data from node 1 and node 2 together and put it in a single place. Okay, like a cat 1 here itself. Okay, and in the reduced task, it will do an aggregation. Since this will be created as a this will be considered as a list and it will aggregate these two results. So cat has occurred twice. That it will give that reduced task will do that. So this code we will write. this code for the mapping to create a general intermediate result, we will write. Other things are taken care by the framework itself. Once the output is given, it based on there is an output format also. Okay, output format is whether it is a text or whether it is a whether means key value pairs. How it is? It is a streaming data or text data. That format it will write the data into the HDFS. So the flow is like um, these are the things which are happening in a MapReduce job flow. One that is the input data, the text format first divides into input splits. That will go to the record reader phase where it will generate a key value pair, which is going to the mapper. Okay, which is going to the mapper. This is where our programmer code is written. Okay, that will give a key value, intermediate key value, that we call it as intermediate key value. That goes between shuffling and sorting between different nodes. Okay, and there is a combiner phase. This is an optional I told you. And the reducer phase will, sorry, partitioner phase will decide how many reducers are needed for after the shuffling and sorting to aggregate the result. Okay, here shuffling and sorting will give a list, right? To aggregate the results, how many reducers are needed, that will be decided by the partitioner, sorry, practitioner, and not part. It is partitioner. Sorry, this is wrong. Not practitioner. It is partitioner, and the reducer phase will give the aggregated results. It is also possible that in some of the flow, right, in the MapReduce jobs, you don't need a reducer phase at all. What does it mean? Reducer does an aggregation, right, or group by, you can think of group by of a data together. Say, for example, the mapper itself is giving an output like all the words had occurred only once, not twice. Okay, if you can understand that from your input data or from your input stream, like every movie which you are giving to the map reduce job has been viewed, okay, only once, or has been rated only once by the user. That time you don't have to do aggregation, right? So you can reduce, you can avoid the reducer phase, you can avoid the aggregation phase. In that you don't have to write the code for aggregation. Okay, that is also possible. Like you can only have a map phase, you don't have to have a reducer phase also. Okay, so this is how the input split happens. Okay, I will tell. Okay, what I think is we will continue with this in the next class. Why? Because okay, I will tell. But if it is not understandable, or you have any doubts, you tell me. I will explain in the next class also. Okay, okay. This flow is fine. Can you tell me? This flow, did you understand? See, you can ask me like a node 1, node 2. Again, it is written into the node 1 only. Again, it is written into the node 2 only. Because it is a duplicated data, right? You remember you are taking a duplicated data from node 1 also and node 2 also. The processing happens on that node and it again stores in the HDFS itself. Okay. So, can I continue further? Is this a flow okay for you all? Okay, for others? Okay. Uh, is it, I mean, overall, can you picture something, or, I mean, how is it? Is it a vague, or is it like we are not understanding anything and all, something I'm saying? Are you feeling like that? Okay, this flow is fine. No, this flow, what are we writing and what is internally happening? We touch upon only the two places. Okay, as a programmer, we normally write, somebody asks you to write a map reduce job, they say like how see the number of ratings. Okay, the ratings for each of them. We will see a movie record. Okay, rating for the which movie has got the uh, you got it in bits and pieces. Write the code. Okay, we will do it. It will be fine. It will be fine. The thing is, it will be fine. Once you 2 3 programs we will write, okay, then it will be understandable. This is how it will be, but by end of a map reduce in 2 classes we can finish it, but you will understand it. Okay, so as I told, like if the number of times a movie is viewed is rated, what is highest rating for a movie? Okay, that if you wanted to do it, how you can do it using how you can write a map reduce program. Okay, we will write one code also like that. That is a real time scenario, right? Like how many times Hadoop is searched in Google, or how many people are hitting that page, right? Or how many people are viewing Facebook some clips, movie clips, or some feeds, how many times they are putting the feed, the ratio of and see what you can do in your project thing is, uh, you can store your data, because now you will work on a data set, right? That's how you will proceed with your project. What you can try to do is, whatever the data set you are going to work on it, rather than keeping it locally, put it in hdfs. Okay, it means you will have your Hadoop setup. You can have your single nodes cluster also. If multi-node is not work, it will work, guys. Multi-node will work. Okay, some more commands are there in multi-node, I will show it, because one or the other time it is not working, but I will show it. So it will, you keep your data in your hdfs. Okay, then mm, you can do an initial analysis. Okay, initial analysis, say for example, if it is a word count program only you are going to do as a project. Okay, initial analysis gave, right, like this word has occurred twice, this word has occurred 3 times. So this output you can feed it into your machine learning logic, and you can give show the graph, right? You can use that, or anything to show your graph, like how the or any histograms, or you can also again apply the machine learning logic into your data set. So try to do like that your project, okay, as a complete project. It is how it is in the industry also, because the huge amount of data they are applying machine learning on a huge amount of data only, where they store it in a distributed environment. Okay, so likewise you try to do that in your here itself, in your project itself, then you will have a hands on in that. Okay, so we will continue further in the next class. Tomorrow we will have this only, right, MySQL class only. In the next class I will describe little more in detail, and 2 3 programs we'll write the program in Eclipse also. Okay, there you how to generate jars and all. MapReduce, you will have a program. Okay, you will have a question in MapReduce, you have to execute and write it. It is easy, only thing is the workflow and all, you have to understand it. Okay, so any further doubts you can ask me. Lab 4 for MySQL, lab 4 not lab 5 I think, for until yesterday we saw commands, right? That I will put it in portal. You start working on that. Tomorrow we will see views, so weekend you can work on that. Okay, so try to revise all the things. Okay, don't forget it. Java you will have in touch, because you will write some programs here, and then it will be okay. Anything else you can ask me, otherwise we can leave for today. And if time permits, start reading, buy that book also. If you are going to take see career in data science, you can buy the books, whatever is given the books, no, you can buy the books and keep it with you. Okay, if you keep parallelly reading it, it will be very good. And for any references, try to refer the authentic sites. As authentic sites, like I showed, right, like MapReduce2 that is Apache Hadoop site. Okay, refer those sites. Don't you can read it. You can any errors and all. You can check it. But for MySQL, especially, they will have a documentation file that you can go and see how it is actually working. Okay, that it will be good, rather than seeing in other tutorials and all. Sometimes they will have a deprecated commands also which is working. So likewise you can search. Book I have put it in Vidya portal, Saurav. Hadoop definitive guide, Hadoop in all or O relay book, Hadoop in practice, Hadoop in action. You first start reading Hadoop, the definitive guide. Don't go for practice and mm, in action. Hadoop in action, Hadoop in practice. Don't go for that book. Start reading the Hadoop definitive guide. Okay, that is very good. I have put it in the portal. You can check it. Okay. Okay. Then anything you can ask me. Otherwise, you can all leave. Please ask your friends to join the class. Okay. Why it is very low attendance is your people are not attending. Any other problem you are, I mean, anyone told like why they are not attending? You can share us any difficulty if you are facing it. Try to resolve. Okay, then thank you all. We'll meet in the next class. Okay.